Today I'm going to talk about the work that we did at Waterloo International Terminal and present the case study of our involvement in the demolition works at Waterloo with the theme of risk reduction through design. The project was part of Network Rail's £600 million regeneration of Waterloo's International Terminal, which included partial demolition of the existing structure while the station was still live, as well as some structural alterations, service strip outs and disposal of some disused Eurostar facilities. So this is what the station used to look like. It was the terminal to Eurostar. Through a series of site works, this is what the finished product looks like. A nice airy space with ease of access to the platforms underneath that arch structure, and also some room underneath for some retail space. The project team was, the client was Network Rail. The principal contractor was a joint venture called the Wessex Capacity Alliance, which is a great name. Sounds like some kind of team. That was a part of Skanska, Colas Rail, ACOM and Mott MacDonald, and then the demolition contractor was Coleman and Company. I was the lead designer for temporary works as Andun, working for Coleman and Company. The main package of works at Waterloo was in the removal of a large steel truss bridge, which you can see in this photo here, which was taken during the middle of the project, really. And also the demolition of the track support structure that was behind. The aim of the scheme was to remove the structure that used to serve the long Eurostar trains, now that the Eurostar had been moved to St Pancras Station. So effectively the platforms that are very long that you can see going off into the distance under that archway could be shortened. It included the removal of around 2,000 tonnes of concrete over about a 15-month programme, all carried out under within a live station over the top of the station's underground station. The Bakerloo ticket hall was just under departures level, which is directly under those props that you can see under the front truss. The package was completed on time and with zero riddles. So the first task was the bridge. First propping was installed to the bottom chord of the front truss, which you can see on that photo there. This enabled the truss to be dismantled, but more cleverly allowed plant to operate on top of the deck, as opposed to operating on top of departures level, which was directly above the live Bakerloo ticket hall. This ticket hall was a key risk that influenced a number of the demolition methods and thus the temporary works on the job. All the risks were communicated to contractor via drawings, a bit like this one, which shows the mega shore, and step-by-step sequences were provided as well, just so that we could communicate the exact step-by-step sequence of how we envisaged the structure would be dismantled safely. These designs were produced collaboratively with the demolition contractor and the principal contractor. I made the effort to share concept design work as design progressed to ensure that the most efficient design was implemented and was constructible. As I say, I was the lead designer, but I was also based on site for a section of the work, which provided a close relationship between designer and the contractor, which meant for a very efficient design process and a very clean communication line. I could also just pop out and have a look at something which I was possibly struggling to find through photos and archive drawings. I could just go out and just go and have a look at it with my own eyes. The propping sequence was all modelled in a frame analysis software, removing sections of the cord as shown on this sequence bit by bit, element by element, to check the stability during demolition. And we produced these drawings so that they could have a clear understanding of how we thought that the whole structure could be removed safely. So this is a photo of the front truss removed, propped down to elevated structure. The next step was to sit a Brock 260 demolition machine on top of the deck that you can see there, and remove the slabs working from one end to the other. This mitigated the vibration going down into the level that acted as a ceiling to the Bakerloo ticket hall. And then once that deck was gone and propping removed, then it was the case of removing a truss that was pinned to the track support structure. That was carried out using a spider crane operating on departures level, which was justified putting mats down underneath the legs of the spider crane and justifying the loadings into that slab. That formed a milestone in the job, and the removal of that large structure, the four-bearing structure that sat above departures level and opened up a lot of space there. The next job was the track support structure. This included removing the structure back to grid line 3, which you can see on that image, on that drawing on the bottom left-hand side. There's a lot of red hatching. That was what we had to demolish. And this image here shows some of that sequencing of the track support structure being removed. Now, the track support structure was essentially 2 stories above basement level, and it carried trains, Eurostar trains. The demolition was incredibly hard going. You can see from this photo how heavily reinforced that structure is. The crusher, that's a Brock 400 machine, sometimes had to go with it with the cracker attachment twice in one spot just to crack the concrete. It was hard going and slow work. The Brock, if you're not familiar with a Brock, that's a demolition machine, a robotic demolition machine, which is remote controlled. You see the little chap on the right hand side of the picture at the bottom. So he's got a remote control there, and it's linked up to the Brock with an armoured cable, so he can be removed from the hazardous area where the demolition is being carried out. And also it gives him a bit of a different perspective of the demolition as well. He can walk around and look at it from a different perspective from a bloke in a cab would do. When this Brock was attacking this track support structure, you could see the hoses pulsating as the thing squeezed and cracked the concrete, because it was incredibly slow growing work. And you may think, why use the pulverizer, the cracker? Well, this was because the peckers or hammers, which can also be used as an attachment, which would have been quicker, they were just too noisy to use in the day, because we were carrying out the works sharing the space with the open air Waterloo railway station, so we didn't want to disturb the rail passengers on their commute. All designs were produced with 3D sequencing, just to demonstrate what we expected the sequence had to be for the critical critical works which were required for the structural stability. And the designs were also Cat3 checked because of the proximity to the railway lines. So once the slabs and some of the ramps down that used to go down from the platforms onto that truss bridge structure, once they had been removed, the next stage was to remove some primary beams. Now you may see, I'm getting a little pointer out here. So the slabs in the centre have been removed, and you'll see some of these primary beams, they're being removed. These purple splodges are column points, and the permanent works proposal required us to remove the primary beams past these column points, but still keeping a lot of the beam intact. So this required us to do some interesting propping work, especially because the raised track support structure did not line up with the structure that was underneath, very frustratingly. So we had to prop back to strong points in the structure, which you can see on this drawing here. And that meant that we had to produce, put in some triangular frames propped back down to masonry, big thick masonry piers which were in the basement. So this interesting propping scheme was implemented to support the permanent works proposal. The driver behind, which you can see on the drawing, that it's that red hatched area above directly above the column. The driver behind the permanent works design, and therefore the demolition scope, was because post-fixing rebar to the existing structure did not give the guarantee of 120-year design life, because resin hasn't been about that long. Therefore, the structure was hydro-demolished to allow rebar insertion and then recast after that. This added a significant risk to the project and significantly increased the temporary works that were required. We designed the propping to avoid those, go back to the strong points. And also the propping had to take into account that we didn't want the beams, the primary beam, to deflect at all. So for when they would recast after. So there was significant loadings involved, and with preloads as well. Some of these frames took loads in excess of 100 tons. So a little bit about, so this is a picture on site. You can see that triangular frame there, and I'll get my pointer out again. What the permanent works proposal was to create an edge beam that ran along the tops of these columns, perpendicular to these large primary beams. If they would have put in some drilled and post-fix the rebar in there to recast the edge beam, to cast the edge beam, then we wouldn't have had to put these big props in. But because they had to hydro demolish, and hydro demolition is basically the most powerful jet wash that you've ever seen, blasting away all the concrete and leaving the rebar mesh behind. It's an incredibly noisy activity, and they're carried out in this the little shroud that you can see at the top there, because it's so noisy and messy, a lot of water runoff. They're effectively taking out the support for this beam, which spanned about 12 meters, 1.8 meters deep, 600 wide. So they were very high loads. And most of the primary beams had this scheme. Some of it was value engineered. This is the other side. You can see there the props down the bottom, and it was quite high risk, but it was the most practical way to deal with a beam like this. There were some other areas which were value engineered and taken out, so this was one of them. The green hatching that you can see there was what they had to hydro demolish, and that pretty much went to the mid span of the beam. We developed some concept ideas of design of how to prop this and support it without the whole beam come crashing down. Essentially, we produced a risk assessment, and I sat down with the demolition contractor and the principal contractor, and we just said, no, it's too risky. It's fraught with risk. It's very difficult to deal with the loads that we've got there. We might as well just take the whole beam back to the next column and then construct it from there. Here's another photo of some of the slab propping, and then another an area where they've hydro demolished above a column. The propping behind this column was a bit simpler because we had handily a nice big masonry pier below, so we didn't have to have a triangular frame. But this next photo was a tricky one, to say the least. The locations of the strong points below in the basement meant that we had to have an asymmetric triangular frame. This triangular frame, being asymmetric, was a very tricky customer. We wanted to preload the frame so that the primary beam didn't drop under the elastic shortening of the props and bedding into its foundation. So we designed a pinned frame with ties, tension ties at the bottom, which were then preloaded with hollow ram jacks. The idea being that as you shorten the bottom ties, then you'd put a preload into the top. You may notice that it's a 4-pinned frame, also known as a mechanism. We had to be careful here that we didn't induce a failure of our propped mechanism. So what we did is we made sure that the top bracket was fixed very securely to the primary beam. I also had a return, which you can't see there, going up into the towards the platform top, which was then fixed into the side of the primary beam. And then the primary beam also had a slab either side, so it was it was restrained effectively. So that's how we dealt with that issue. The propping was drawn up, and we controlled the quality of the propping. I inspected it on site. That's one of my photos when I went around and inspected it, and also controlled the design by issuing the designs in draft for comment and checking, and then also issuing with a for construction stamp at the bottom, as you can see on the bottom left hand side of that drawing, just to show that the design has been checked and it's for construction, so it can be built on site. This is some removal of other areas, which was carried out in a more quieter methods of demolition. No hammers, no breakers or hydro demolition. It was cut and lift using a spider crane. This is one of the primary beams that was being taken right back to one of the column points. So we propped the beam and removed it in sections using a spider crane. This was carried out during the day whilst the station was open, and there's much quieter and a controlled method of removing that primary beam structure there. Here's another photo showing some of the other areas of work while that primary beam was being removed. You can see there's some raking props to column points there to make sure that the columns, once their head restraint had been removed, once the primary beam had been removed, to remove their head restraints, we put some raking props in there to ensure they remain stable for when the permanent works structure was installed. Plenty of scaffolds and things going on, so we had to control the loading of the slab to make sure that the loads that we are having from the props, spider cranes, any plant and the scaffold was controlled and within the capacity of the elevated structure. So the job was completed in summer of 2018, and also won the award at the World Demolition Summit for the job in civils job category. There were several ways in which we reduced risk by design during this project. Collaboration being a key one, collaborating of all parties involved, the designers, the demolition contractors and the principal contractor, working jointly on the project to explore the methods and eliminate or reduce the risk where they can't be eliminated. All work was carried out. All work that was carried out was Cat 3 checked, and we worked closely with the demolition contractor, principal contractor, as well as Network Rail. Works adjacent to the railway, which is the live railway, were submitted as part of the Form 2.3 procedure. The designer being based on site, that was very handy, and it meant that I had a very close, intimate relationship with the site team and the structure as well. Which did help through the design process. Draft issued drawings to the contractor, Coleman's and Skanska, mainly the principal contractor, so that the design of the demolition was based on a collaborative approach and eliminating risks, which was absolutely key to a successful project, in my opinion. So this is a structure coming in. It's being constructed, the permanent works being constructed so that you've got a nice easy access to these platform areas, which is that bridge there, and this is what it's supposed to look like when it's completed, with all the retail units in there. And then this is a photo of all Coleman's when they finished the job on the last day of the job for them. So